So today we are talking about congruent and similar triangles. Congruent. What does congruent mean? Exactly the same size, the same shape, the same angles. Meaning that the sides are equal and the angles are equal when we talk about triangles. So these two triangles are congruent. When triangles are special in the fact that if your sides are all congruent or the same, then your angles are also going to have to be the same. Okay? You cannot have sides that are different lengths and have same angle measurements unless they're in proportion to each other. Okay? So triangles are kind of special like this, and they have some special properties that we're going to talk about. But if all the sides are equal, then they are exactly the same triangle. Makes sense, right? So the first thing we're going to talk about is an angle-side-angle relationship. And when we talk about this, we know that in a triangle we have three sides.
Really?
I know, right? I'm like, oh, why are you doing that? I wanted to draw a picture. Three sides. So when we have an angle and a side and an angle, if those are the same or proportionate in any triangle, we know that they are going to be similar triangles. Okay? This side and this side and this angle have to be in proportion if these three things are the same. An angle, a side, and an angle. Now it could be this angle, this side, and this angle, or this angle, this side, and this angle. But as long as you have a side trapped by two angles that are proportionate to another one, they are going to be similar. So when we look at this one, we have this side is 45 degrees, this side is 35 degrees. Same here. This is 14 and this is 14. Those are the same, so these are congruent triangles. They are exactly the same. There is no way that this last angle that they do not measure can be a different from each other. They have to be the same. Mikey, what are you doing? You could probably close that and pay attention to me. Yep, exactly. Okay, so angle, side, angle is our first thing that we talk about when we talk about congruent or similar triangles. Then we can talk about side, side, side. If the lengths of the three sides are the same, then your triangles are congruent. If they're proportional to each other, they are similar. It's what we just talked about. If all three sides are the same, obviously you have the same triangle, right? Pretty basic. Then we talk about a side, an angle, and a side. So if you have two sides that are the same and the angle between them is the same, your triangles are congruent. There is no way to draw a different triangle from two sides and an angle that is going to be different. So they have to be congruent with each other. So if we have this side is 23, this angle is 50, and this side is 14, this one is the same. There's no way to make this side or these two angles different. They have to produce the same triangle. Make sense? Following along a little bit? So, are these two congruent? And this should be on the back of your paper. Yeah. Are these two triangles congruent? When we look at them, here's something we need to remember. We have to have the same angles in the same spot. This 90-degree angle has to correspond with this 90-degree angle. So even though they've rotated their triangles, those are still the same angle in that triangle. So if we flip those around and make those match up, are these congruent?
Yeah.
So that's all you put is yes?
Yes.
That feels too easy.
I know, right? It is pretty easy. This next one, I went across on our paper on the back this time. So are these congruent? Why not, Austin? 105 and 107. One has 105 and one has 107. They do both have that 37-degree angle, and they do both have a side that is 45. However, one is 107 and one is 105 degrees for my third angle. So we know using that angle side angle theory that they are not congruent triangles. So then we talk about similar triangles. The definition of similar is on the front of your page. Similar triangles, the corresponding angles have to be proportional, meaning that they can reduce down or multiply up to each other, okay? So we can have one triangle that is smaller, another triangle that is bigger, and as long as they are increased proportionally to each other, we have congruent or similar triangles. Mikey, please close your Chromebook.
Why?
Because I asked you to earlier, and you said you were going to, and now it's
I don't think
not.
hurting anybody.
It's hurting me.
Why?
Thank you. It's hurting my heart.
I don't think so.
But you're not paying attention to me. I want your full attention when I'm up here. So it hurts my heart when I look back and you're not giving me your full attention. So it's hurting
Never
me.
give my full attention.
Yeah, let's try. Let's try for the next 10 minutes. All right. So, in similar triangles, we can take one triangle and blow it up and make it bigger, or take the bigger triangle and shrink it down as long as it is proportional inside. So this increases by side A to side D. We have to figure out which sides match up, right?
Double.
So A to D would be a times 2. B to E would be times 2. And 8 times 2 would give me 16. So these are proportional because we're multiplying all the sides of one triangle by the same amount to get to that other triangle. They can set it up in a proportion, and they show that it is a proportional or similar triangle. So, example 2, this is on the back of your paper. Find the ratio for the corresponding sides of triangle QRS and XYZ. So we go from this side is, and this side is, so our ratio is 9/13. If they were to give us the length of one of these other sides, we would have to set up, like say this is, and I don't know what kind of math, this might work out as a fraction or a decimal because I don't know how it's going to work out. But if they tell us that QR is 2, what is the length of XY? Then we can set this up in our proportion and say that we know 9/13 is our original proportion. They gave us a side that matches with 9, so our number goes on top here. Then I have to solve for what this is here. And you all know how to do that because we've been doing that for weeks now, right? We're going to cross multiply 13 times 2. Give me 26 and divide that by 9. And that's going to tell me how long this XY is.
Probably it is.
It is going to be a decimal for sure. For sure. Okay, that is a little extra. I don't know that you need that information yet. However, I just want you to know that that is what we're going to do to find those missing numbers. Oh, nope, just kidding. Here, they give it to us on this one. So, here we have two triangles that are similar. Because it tells us they are similar, we know we can set them up in a proportion. Which two sides do we have that are the same that we can use for our proportion? 9 and 6. And it doesn't matter if you put 9 over 6 or 6 over 9, as long as you keep the numbers from the same triangle either on top or the same triangles on bottom. So if I put 9 over 6, then I have to put the 5 up here with my 9. If I put 6 over 9, then I have to put my 5 down here with my 9. My 5 has to stay with my 9. Cross, multiply, and divide, yep. When I cross multiply those, I end up with 30. 30 divided by 9 gives me 3 and 1/3. So x is 3 and 1/3. Okay, finally, in word problems, we can set up the same kind of proportions. Hello, sir. Here you go. Take this. You're going to want it. Yeah, no problem. So we have a firefighter who's fighting a fire in a burning building. She says the length of her shadow is 8 feet long. And the length of the building shadow is 60 feet long. She is approximately, the approximate height of the building, find the approximate height of the building if she is 5 foot tall. So these two triangles that we're making between our firefighter and our building and their shadow, they are similar because they are in the same ratio to each other. So we can set this up in a proportion. We have 5 over 8 or 8 over 5, whichever way you put it. 60. And then you just cross multiply and divide to find that missing length of how tall our building is. So the first part of our assignment will be determining whether these are congruent triangles or not congruent triangles. And our second part will be finding those missing numbers. It might ask you, how do you know these are congruent? If it gives you 3 sides, you have to put in that it is the side reason we know they're congruent. If it gives you 2 sides and an angle, side, angle, side. If it gives you an angle, side, angle, you're going to need to look at the front of that paper and tell me which one of those it is going to be in Y. Then it's going to ask you to set up ratios of congruency. So you're going to set up that ratio. Then it's going to ask you to find those missing numbers. Any questions over any of that? Okay.